Hello everyone, today we discuss about the optimum statistical classifiers. This is the overview of the topic, Introduction to Statistical Pattern Recognition and Classifiers. So in this topic we see a probabilistic approach to the recognition purpose. Probabilistic consideration become important in pattern recognition because of randomness under which pattern classes are normally generated. As you know, pattern X may belong to any one of the W classes. Under consideration, the average loss incurred in this assigning X to class omega suffix j is R suffix j of X. This equation also called as conditional average risks. The classifiers that minimize the total average loss is also called the bias classifier. Thus, the Bayer classifier assigns an unknown pattern to omega suffix I, or in other words, X is assigned to class omega suffix I if the conditional average is less than or summation operation. This is also for all values of j, whereas j and I are unequal to each other. Bias classifier for Gaussian pattern classes. The Bayes decision functions have the form to represent as these equations, where the patterns are now scalars denoted by x. Figure shows a plot of the probability density functions for the two classes. Probability density functions for two one-dimensional pattern classes represents the horizontal axis x and the vertical axis represents the probability density. And this figure a simple arrangement of two pattern classes in 3 dimensions. We use these patterns to illustrate the mechanics of implementing the bias classifiers. And here some of the design recognition. Design recognition system requires selection of training and test samples, definition of pattern classes, sensing environment, pattern representation, and classifier design. And this is the pattern recognition application. Here we see the problem of domain and the application of recovery. Yes, we see that problem of domain, bioinformatics, data mining, documentation, classification, and here some of the applications: sequence analysis, searching for meaningful patterns, internets, and their input patterns, and pattern classes, and pattern recognition models. We see the approach, representation, recognition function, and the typical criterion. In approach, template matching, statistical, synthetic or structural neural networks. In representation, samples, pixels or curves, features, primitives of the structural, samples, pixels, features of the neural networks, and some of the recognition function and typical criterion. Statistical approach. Each pattern is represented in d features in d-dimensional space as a point. Objective to establish decision boundaries in the feature space which separate pattern of different classes. Discriminant analysis based on approach for classification using mean square error criteria construct the decision boundaries of the specified manner. Here d features dimensional feature space. System is operating in two modes, training and classification. In classification, test pattern, preprocessing, feature measurement, and classification. And in training, training pattern, preprocessing, feature extraction selection, and to training, learning to classification. Here the problem was to classify areas such as vegetations, water, and bare soil. Figure shows the resulting of mission classification using a Gaussian bias classifier, and this we know that how statistical and pattern recognition work. Here we see some of the new infrared wavelengths masks, all classified as water, result of classification, and by this we know how statistical and pattern recognition works. Thank you.